All right, so this lesson is going to be one of those where we're looking at different sets of data and we're determining what's good to look at and what's bad. What kind of shows you what the real answers are, or which things are trying to trick you. So today our goal is to learn to describe and compare data distributions by their center, spread using box and whisker plots, or looking at a dot plot. Write this down before moving on. And here is your warm-up. I want you to find the median of each data set. So remember, that's the middle number. You got to reorganize them all and then give me the answer. All right, so your answers for this one, for number 1, it should have been 9. Number 2 should have been 9. And number 3 was 5.9. That one was a little more work. Okay, if you got those all right, I want to hear you go, whoop, whoop. All right. Now, recall some of the stuff we talked about before already in this unit. And we talked about frequency distribution and how it's a display that shows how many times data falls into a specific category. Well, frequency distributions are usually categorized in a general shape. They're either skewed or normal. And this table I want you to put down in your notes. So what does it mean to be skewed? Well, basically it means the data is not symmetric. You know what symmetrical is. It's even on both sides. And the measures of the center are not always equal. Well, the opposite of that then for normal is they are symmetric, and the measures of the center are equal. Have this down, and then we'll look at a few so you can see what I mean. Okay, so let's take a look at this set of data. So the data set and dot plot are displayed here, a frequency table, or a line graph, line plot, sorry. And these are all of a heart rate. So when we look at the shape here, you can see that the shape here is symmetrical from the center. Most of the information is right in the center and everything evenly spreads out. So we would call this a normal shape. I want you to put this example down in your notebook so you have an example of a normal shape. Now this would be an example of a skewed shape. You can see these are displays of quiz scores. This is a good set of quiz scores because look how many are at the top. This is a good sign. A lot of you guys work hard, and if you all work hard and get good answers, this is what it looks like. So this data, though, is skewed. Okay, it's not symmetrical. It's very heavy along one side. Okay, the mean, median, mode are varied. So this would be considered a skewed. So have these down before moving on so you have an example of a normal and a skewed. All right, so the data set here and the dot plot display the numbers of kilometers that Jamie ran for each day for 20 days. I want you to take a second to stop and try to describe the shape of this distribution. Are we looking at something that's skewed, or are we looking at something that's normal? Come back when you got your answer. All right, so you probably saw for this dot plot that we're looking at a very normal shape. It's very normal because down the center, all the way to the sides, it's very even. So this one you should have had normal. If you got that, good job. All right, now let's say we're looking at the information from a box and whisker plot. I always think of cats. There's a cute little kitty actually in the textbook on page 271. You can go online later and look at it. Anyways, the data set of a box and whisker plot displays the weight in kilograms of 12 cats. So describe the shape of this data. As you can see here with this box and whisker plot, again, it's not symmetrical, and it's very heavy to the bottom of the box and whisker plot. One whisker is real long, one whisker is short. So this would be skewed. I want you to put this example in your notebook and write skewed so you know what a skewed box and whisker looks like. All right, now tell me whether this is skewed or normal. Pause the video if you need to. Come back when you're ready to describe and explain yourself. All right, you probably noticed that this is skewed because you can see the whiskers are pretty significantly different. And our median is closer to the third interquartile than it is the first. So the data isn't perfectly symmetrical. So you should have had skewed for this one. It's definitely not normal. All right. So for example 3 now, on our third example, last example of this lesson, we're going to compare the distributions using the box and whisker plots we see here. So we have two different box and whisker plots. It displays cars sold each day on 2 different lots in a month. So during 1 month, you can see with lot A and lot B what information you have. So all you got to be able to do is look at the data and explain what you see. Well, the one thing you probably notice that there's more cars sold in lot A than in lot B. The large amount of all the data is further to the right or further up the number line than lot B. So the spread of the data is much greater for lot B. There's a lot of days where they're lower. There's days that are really high, but they're not as consistent as lot A. So the number of cars in lot A is definitely more predictable than the lot of cars sold in lot B. You know, if they gave you an opportunity to work at either lot A or lot B, you'd probably say, I'm going to work at lot A. I have a much better chance of being able to sell a car there. So you can write this down and put a couple of those notes down if you want. You don't have to include this in your notes. All right, so what I want you to do now is write a conclusion about what you see here. This is Amy and Jackson's first semester test scores. So you can see where they're at. You can go ahead and give me information. Look at it a little bit, come back, and I'll kind of tell you what I see. All right, so you should have written down, obviously, Jackson has better scores than Amy. But the one thing you'll notice about Amy is very consistent. Her information is not skewed at all. It's very normal. So her average score is an 80, where Jackson's average score is a 91. But the problem is Jackson's scores have ranged from 80 to 95, 94. Amy's been pretty consistent, right, between 85 and 75. Most of her tests have been right around 80 with a couple outliers at each end. So even though Jackson's got better scores, she's much more consistent. All right, you made it. Box of thought. Go ahead and answer these questions with full sentences. And when you're done, come on back. All right, here is your quiz. 2 questions that you need to answer. Come on back to me when you're done and show me your answers, and we'll be done for this lesson.